We're now starting my favorite part of Calc 2. When I think of Calc 2, I think of two things. I think of integration techniques, and that's what we're going to do in Chapter 8. And then I think of sequences and series. Because those are the two topics that are used in math classes beyond Calc 2. In Calc 3, you'll use lots of integration techniques, differential equations, lots of integration techniques. If you go on classes beyond that, you'll use a lot of integration, a lot of series and sequences, which is the next chapter. Okay, so here's the idea. For derivatives, we had three main rules. We had the chain rule, we had the product rule, and we had the quotient rule. Those were our three big rules of derivatives. What's kind of the reverse of the chain rule? What did we call that? It's the only integration technique we know at this point. It's one we use every day. U substitution. So the reverse of the chain rule is what we call U substitution. U substitution came from using the chain rule. Today we're going to reverse the product rule, and this is called integration by parts. And there is really nothing that corresponds to reversing the quotient rule. Although we will have several techniques for how to handle fractions coming up in this chapter, none of them really relate to the quotient rule at all. All right, so remember back in Calc 1, your good old friend, the product rule. So assuming that u and v are some functions, not just constants, they're some functions, how do you take the derivative of u times v?
U times v prime. Wait, derivative or integral?
Did I say integral? I meant derivative.
U times v prime plus v times u prime.
Okay, so I'm going to write this way. I'm going to write it as u dv. I'm going to use differential notation, plus v du. What happens if I now take that equation, that formula that I have there, and I integrate both sides? What's the integral of the derivative of u times v? U times v, because integrals and derivatives are inverses. So if I integrate on the left-hand side, I get u times v equals, over here I'm just going to have integral u dv plus integral v du. So the way you typically see this written, this is the formula that we're going to use over and over again today 1,000 times. The integral of u dv is u times v minus integral v du. So there's your integration by parts formula, and it comes directly from the product rule. So when will you look at a problem and guess, hey, I think I should use integration by parts?
You've got two things you're multiplying together that you can't get rid of by u sub.
When you have two things that you're multiplying together and you can't get rid of one of them by u sub, that's your big indication that this is integration by parts.
Or if you can use u sub.
Then use u sub.
No, you can't. Will it work if you use that and you can use u sub?
In some situations, yes, it might. But in general, if you can use u sub, use it, because it's the easiest of all the techniques. All right, so here's the typical problem you might see. You might have the integral of x e to the 3x dx. You should look at that problem, and the first thing you should notice is that you do have multiplication. You have x times e to the 3x. That's a big indication right away that this is probably integration by parts. Also, we're in the integration by parts section, so it's a good guess that it's integration by parts. But the other thing you should notice is that U substitution will not work. How come U substitution does not work?
Because 3x can't be used to like cancel out the x.
Correct. I would really need to have 3x squared up there, so that when I take the derivative, I get a 6x, and that would allow me to take care of that x.
Can you still like solve for x and plug it in?
Yes. But I don't think that would help. Let's just do that just to see.
Okay.
If I were to let u equal 3x, du would be 3 dx. So I would need a 3 and I would need a 1/3. I would have 1/3 integral. What would I have to do with this x? X would be u over 3 e to the u du. So notice it didn't get rid of the multiplication. The only thing it did is instead of having the 3 here, the 3 is now there. So unfortunately it wouldn't work. Doesn't help. So U sub doesn't work. Alright, so to use our integration by parts formula, we have the integral of u dv. We need to make a guess. We need to pick something to be u, and then whatever is left, we'll call it dv. So we have two choices. We could pick u to be x, or we could pick u to be 3x. Anybody have a preference?
Or V, you want V to be whatever is easier to everything? Or, yeah.
Sure. V is something we're going to have to integrate, that's true. But I can integrate x, and I can integrate e to the 3x. So that's kind of a wash. You get a 50-50 chance of being right. Do you want u to be x, or do you want u to be e to the 3x?
E to the 3x.
Oh, we're divided. Oh, boy.
Wait, is there like a right answer?
Yeah, one of them's going to work and one of them isn't. So there is a right answer.
I thought this.
So let's do it wrong the first time, and we'll see why it's wrong. And then we'll turn around and we'll do it the right way. So the wrong thing to do is to let u be e to the 3x.
That's not going to solve anything.
And we'll see why that's wrong. So dv is everything left, which would be x dx. So we made our guess. Sometimes you guess right, sometimes you guess wrong. That's just the way it goes. All right, so in our formula, we now need uv minus integral v du. So notice I've got my u is e to the 3x. I need v. How am I going to find v? Integrate. So v is 1/2 x squared. So I just integrate there. And then in this part of the formula, I need a du. So to find du, I'm going to differentiate this one. Du is 3e to the 3x. So using my formula, I would have u times v, that's going to be e to the 3x, times 1/2 x squared, minus integral of v, which was 1/2 x squared, du, which was 3e to the 3x dx. And right now, I would stop and say, crap, I made a bad guess. Why do I look at that and know, crap, I made a bad guess?
Because that won't cancel out to a single term on the left, or on the right.
In a sense, it got worse, didn't it?
Yeah.
We started with an x e to the 3x, and we made it worse. Now we have an x squared e to the 3x. So not only did the multiplication not go away, in a sense it got worse because that power got bigger. So that's how you recognize when you made a bad guess.
So you want du to be like 1, or like to be dx?
Ideally, what you would really like to happen is when you take the derivative right here, you want something to go away. That would be ideal because then that's going to get rid of the multiplication. So knowing that, that tells us that we really should have picked du to be x because the derivative of x is dx, 1 dx, it'll go away. All right, so that's what happens when you do it wrong. Sometimes it's more important to know what happens when you do it wrong than when you do it right, so you know what's happening. All right, so let's try it again. Integral x e to the 3x dx. Doing it correctly, we're going to let u equal x. which means dv is e to the 3x dx. We take the derivative of this one, du is dx, and we integrate that one. What's the integral of e to the 3x? E to the 3x over 3. Very good. Why over 3? Because we're integrating. If you were to take the derivative, you would use the chain rule and you would multiply by 3. So if you're integrating, you're going to do the opposite. You're going to divide by 3. 1/3 e to the 3x. Very good. All right, so now notice when we use u times v minus integral v du, we're going to have u was x. V was 1/3 e to the 3x minus integral v 1/3 e to the 3x, and then du is just dx. And notice our integral got better. And this is the whole goal behind integration by parts. We now have an integral where we're not multiplying variables. That's an improvement. Can we integrate 1/3 e to the 3x? Yes, and we get, because of the same deal, when you integrate e to the 3x, you have to divide by a 3 again. Final answer. 1/3 x e to the 3x minus 1/9 e to the 3x plus c. They wrote down the product rule and they switched things around a little bit. It's really all it is. It's just a rewriting of the product rule.
So why is there no equivalent for division?
Nobody's come up with one yet. Like I say, we will have other techniques for division, the largest one being something called partial fractions. That would be our biggest technique, although trigonometric substitution will actually deal with fractions a lot also. And we'll see those are down the road a ways. We'll see those when we get to them. All right, let's try another one. Integral x cubed ln x dx. Once again, I immediately notice I have multiplication. I have x cubed times ln x. And I immediately, once again, recognize that u substitution is not going to work. Because I could let u be x cubed. I'm not going to get an ln x out of that. Or I could let u be ln x. When I take my derivative, I'm not going to get an x cubed. So u substitution definitely does not work. Integration by parts would be my next guess. Any guesses for u?
The ln x.
U is the ln x. Why do you want u to be ln x?
Because after we integrated, it will be 1 over, oh no, the ln x needs to be 1 in this case integrated.
So you're switching your mind?
No, I just had a momentary confusion which one was which. No, the x3 should be u.
U should be x cubed,
Yes,
and dv should be
ln x.
ln x. U equals x cubed, dv equals ln x dx. Okay, excellent. What's du? du is 3x squared. What's v?
Over x.
No, that's the derivative of ln x.
Oh yeah.
The derivative of ln x is 1 over x. What's the integral of ln x? There is one, but we don't know what it is yet.
Oh.
So what's that tell us? We picked the wrong way again. We're not very good pickers, are we? We picked it the wrong way. Simple as that.
So when we're getting make it
All right, so there's a good rule. Whenever you have an ln always has to be the u because it cannot be the dv because we don't know how to integrate it. So you're absolutely right. U has to be ln, which means dv has to be x cubed dx. I can differentiate. The derivative of ln x is 1 over x dx. Excellent. And v is 1/4 x to the 4th. All right, so again, remembering that my formula is u times v minus integral v du. I fill in all my stuff. U was ln x. V is 1/4 x to the 4th. Minus integral of v, 1/4 x to the 4th, du, 1/x dx. Did that help? Did we eliminate that multiplication problem that we had?
Yeah.
Yes, because x to the 4th times 1/x is, you can write this as 1/4 x cubed. So it didn't all go away, but you can combine terms and write this as 1/4 x cubed dx. And so it did get rid of the multiplication problem for us.
Shouldn't that be 1/4 control x cubed dx?
Yeah, I could take that 1/4 and I could move it out front if I wanted to. Doesn't matter. I'm going to integrate, I'm going to add 1 to my power, divide by my new power, I'm going to end up with a 1/16 either way. Looks like the final answer is 1/4 ln x times x to the 4th minus 1/16 x to the 4th plus c.
Well, you only do this once in a problem.
Oh, you want to do it more than once?
Well, no, I mean, like,
Because
you don't
if you
have
want
to chain
a
rule,
double
like the chain rule, you can just keep going
part.
with it, but.
A double integration.
Is that gonna happen?
Not only is it going to happen, there's going to be double, there's going to be triple, there's going to be quadruple. Oh, it gets gruesome. Why? Why does it get gruesome, or why do we do it?
Why do we do it?
Because we can. That's why we do it.
What are you going to use this for?
I don't know. I had to integrate something that.
Understanding tax code.
Right, understanding tax codes. That's right. Okay, well, I have a good message. Some good news. The good news is you don't have to guess. So far, we've learned we're not very good guessers, right? We got it wrong both times. There's a little acronym which will tell you the order in which you should guess. It works probably 99.5% of the time. Once in a great, great while, this will crash. I don't think it will crash with any of the problems that I see in your homework, though. I have seen it crash in other courses. And the little acronym that you're going to remember is ILATE. And what this tells you is, this tells you what to pick for you. So in this, I stands for inverse trig. So if you see an inverse trig function, it doesn't matter what else is there, that's you. What do you think L stands for? Logarithm. So if there's no inverse trig, but there is an ln, or an log, you don't use logs very often, then that's your u. A, anybody guess what A stands for? This is algebraic. What does algebraic mean? Polynomials. X, x squared, x cubed, x to the 4th, that's algebraic. T stands for? Trig. And last, E is exponential.
That should be a Jeopardy question.
That should be a Jeopardy question. What does ILATE stand for? I don't know where I picked that up. I don't think I've ever seen it in a book. But somebody taught me that some time ago. I don't know when. Okay, so knowing that takes half the trouble out of these problems. So let's say you had the integral of x cosine 5x dx. Using our little ILATE rule, we know right away that u should be x, because algebra comes before trig. So u is x. Which means dv is everything left, cosine 5x dx. This one we have to integrate. The integral of x is
Yes.
dx. I said integral, I meant derivative. You gave me the right answer for the question I asked. The derivative of x is dx. See, he was paying attention. He gave me the right answer. I asked the wrong question. Over here we integrate. What's the integral of cosine 5x?
Negative sign.
Negative sine 5x.
The derivative of cosine is negative sine. The integral of cosine is positive sine. So this is going to be
Sine 5x over 5.
sine of 5x times a 1/5. Why are you dividing by 5?
Go backwards.
Chain rule backwards. That's exactly right. Technically, that's a u substitution problem. I don't expect to see the u substitution written out there. I expect you to understand that if I took the derivative, I'd have to multiply by 5. So if I take the antiderivative, I have to divide by 5. All right, so here's our answer. U times v. U was x. V was 1/5 sine 5x. Minus the integral of v, which was 1/5 sine 5x. Du, which is dx. Hopefully, you've gotten rid of the multiplication, and you're now to the point where you have something you can integrate. Can you integrate 1/5 sine of 5x? Yeah, it's almost the same as the integration you had to do here, isn't it?
1 times cosine 5x.
How about 1/25?
Oh.
5 times 5. And this should be a negative, and when we integrate again, we're going to get another negative, so it's going to be a positive. Final answer. 1/5 x sine of 5x plus 1/25 cosine of 5x plus c.
How do you want to rewrite it on the test?
What's that?
How do we write this when you want it on the test? How do you want to write it?
Just like that would be wonderful.
Just curious.
So when you said like there were like we wouldn't see functions that would trip us up, does that include like functions where you have to kind of shuffle like trigonometry stuff around before you can do anything with them?
Not in this section. The next section is trigonometric integrals. So the next section, there will be lots of shuffling of trig functions around.
I still have nightmares about that when I sat in close.
So,
We'll see. That's coming up. By the end of the week, we'll be into trig integrals.
I spent the hours doing.
Yeah, it's a tough section.
what if there were 3? Like, in that one we have x and cosine 5x. That's 2. What if there was 3?
What if there was 3?
3 variables, you know what I mean?
Yeah, I know what you mean. If there were 3, then traditionally integration by parts wouldn't work. And you'd have to try something else. But maybe it would work if you could let, the whole key would be, would there be something there that you can integrate? And then when you take the integral and you compare that with the derivative, is something going to cancel out? So you'd have to let u be a single thing would be my guess. And then dv would be something with a multiplication in it that you could do a u sub on. And that would cancel out one of the 3 things, and then you'd be down to 2. And hopefully it would work. But that would be unusual. You don't normally see problems like that.
I don't usually see problems like this.
That's true, but you will now.
So what does it look like when you have to
What's it look like when you have to do it twice? We'll get to that. Maybe not today, maybe tomorrow. We'll see.
Yeah.
Before we do that, you guys have asked me about this one many times. It's time to answer it. What's the integral of ln x? Well, this isn't one that you would think of for integration by parts because there's not multiplication. But it turns out that integration by parts works anyway. According to ILATE, what's U?
Natural log.
Well, it's the only choice, right? It's the only thing there. U has to be ln x, which means dv is everything left. The only thing left is dx. 1 dx, that's correct. Take the derivative. du is 1 over x dx. And over here we integrate. V is just x. All right, plug that in. U times v. U is ln x. V is x. Minus integral of v, that's x, times du, 1 over x dx. Well, that works out very nicely. The x's cancel out, and you're left with the integral of 1. The integral of 1 is x. So here's the answer. X ln x minus x plus c. So now we have an answer for the integral of ln x. That's correct.
Yeah, it's a lot easier than I thought it would be.
What's that?
It's a lot easier than I thought it would be.
It turned out to be a lot easier than it looked like it was going to be at the beginning. That's true. However, you still never want dv to be ln x, because then you're going to end up with something that's even worse than what you started with when you integrate it. You still always want u to be ln x, so that when you take the derivative, you get 1 over x, you get rid of that ln. That's why L comes so early in ILATE. You always want u to be ln.
If you, let's say you did make dv ln x, if you kept going with it long enough, would you break it down and get the correct answer? Or would you just keep going down like an infinite loop, so to speak?
My guess is you would go down a dark, dangerous path. I'm guessing it wouldn't work, mostly because when you integrate, you end up with a multiplication there, so you're not getting rid of the multiplication. So my guess is it would simply get worse and worse and worse. It would never get better. But I don't know that for sure.
Okay.
Would depend on the problem. You could probably concoct a problem where letting dv equal ln x would actually work out nicely. I don't think I've ever seen one. Other questions? All right, so you want to do one where we have integration by parts twice, huh? All right, we can do that. What do you think you need?
Really crazy equation.
No, you don't need a really crazy equation. How come this one only needed integration by parts once?
There's 2 elements.
There were 2 elements, that's true. And what happened when you did your u and your dv thing?
And u is in both terms.
The u was here, but when I took the derivative of it, it went away. That got rid of the multiplication right away, didn't it? So when would we need integration by parts twice?
Over like x squared or something.
If this started as an x squared. Because then I'd take the derivative, I'd get a 2x. I'm going to have to take the derivative again to make it go away. So it doesn't have to be really crazy. Something fairly simple like x squared e to the x will do it. Once again, you should recognize that that's an integration by parts problem because you do have multiplication and u substitution doesn't work. But the ILATE is still the same. ILATE says u should be, which one? X squared, because exponential comes last. U is x squared, so dv is e to the x dx. Take the derivative. du is 2x dx. Integrate over here. V is
E to the x over x. Right. Yeah, what am I saying?
just e to the x. The derivative of e to the x is e to the x. The integral of e to the x is e to the x. E to the x is your favorite function. It's its own derivative and its own integral. All right, using the formula u times v, that's x squared e to the x, minus the integral of v, that's e to the x, times du, that's 2x dx. So notice what happened. We started with an x squared e to the x. This new integral that I have has an x e to the x. Unfortunately, it's not done, but it is better. The power reduced. I went from an x squared to an x. But I unfortunately still have multiplication in there. So that tells me, what do I have to do? I have to do it again. I have to do integration by parts again. So I do it again. This time we're going to pick u to be 2x, the algebraic thing again. U is 2x. So dv is e to the x dx. I differentiate. du is 2 dx. I integrate. V is e to the x. All right, so we have the x squared e to the x out front, minus, and then I got to put a big thing in parentheses here because I got to subtract the whole thing. U times v, that's 2x e to the x, minus the integral of v, that's e to the x, du, 2 to the x. Now we're in wonderful shape because now we've gotten rid of the multiplication altogether. We're just left with the integral of e to the x, which is e to the x. Final answer. X squared e to the x minus 2x e to the x plus 2e to the x plus c. So was it as bad as you thought? Not too bad. I made this one actually pretty easy. How could I have made it harder? Put a number up here in the exponent of the e. Like if I had an e to the 5x, why would that make it harder? Because then when you integrate, you would have a 1/5 e to the 5x, and then you'd have to mess with all those fractions, and that would make it harder. How would I make it if I wanted you to do integration by parts 3 times? X to the 3rd. If I wanted you to do integration by parts 10 times, x to the 10.
Is there an easier way to do that? Or you guys want to draw out,
There is an easier way to do that. We will do that tomorrow.
like, chain rule family?
No, there's something called tabular method for integration by parts, and that's what we'll do tomorrow. No, not like matrices at all. I do have one final question, one that nobody's asked me yet. And I'm surprised, every time I've taught Calc 2 in the past, somebody always asks me this question. You guys didn't ask me. How did I go from this dv to this v? I did an integral. When I integrate, shouldn't I put a plus c right there?
Well, it's the same, so I guess you don't have to.
But then that plus c is going to be in with this integral. It's going to be multiplied by this 2x.
You should carry it down.
Carries down. Are you going to get the same answer?
Because it's just constant.
Yeah, but think of what you're going to have in here. You're going to have e to the x plus c times 2x. So you're going to have to integrate e to the x 2x, which is what we had to do. But you're also going to have an integral for 2x times c. That's like a cx squared, isn't it? But we don't have a cx squared down in our final answer.
No,
You don't want to just be-
All right, so should you put a plus c there, yes or no?
No.
That's actually going to be your next lab. In your next lab, you will experiment with what happens if you do put a plus c there as compared to what happens if you don't put a plus c there. Do you get the same answer or do you get a different answer? That's your next lab that I will pass out on Friday. It's not too bad. It's actually a pretty easy
I
lab.
can fun see, like,
I will say now.
I just really want to see.
But is it less C, but